I'll start this presentation with a question. How is it possible to reduce energy costs by utilizing the building design? By studying green building principles and becoming a lead green associate, many factors for green building design have been taught to the interior architecture and design class. Through learning these principles firsthand, I was able to utilize some of this knowledge in designing a passive solar building for Lahaina City in Hawaii. This is a conceptual building. The process started by sketching out ideas of what the building could look like and by emphasizing certain energy efficient features for the building. This is done during the design development phase and schematic design phase. This building contains overhangs on the south for sunlight control in the summer months, as well as apertures and ability of windows to distribute light into the interior space in the winter months. Bronze rain screen walls on the interior help absorb some of the energy and retain thermal mass, as well as the concrete slab floor. The sunlight that enters the interior space from the windows distributes heat and energy at a more continuous rate. Findings. Through secondary research, I have discovered that passive solar design and heating of buildings is a dynamic process, and solar energy is transmitted through glazing and then absorbed by interior building components and released to the indoor air over time. Building design above technology is a relatively inexpensive way to reduce energy costs for buildings. By reducing the energy consumption of buildings, you lay the foundation for a more sustainable and regenerative society. There are 5 elements to passive solar design. The first is control, then aperture or window, distribution, absorber, and then having a thermal mass to absorb that energy. So you can see on the top right of this presentation, I've documented where those features are. So I've got large overhangs on the south, which are the control. Large windows to allow the sunlight to enter in the space in the aperture. Then we've got the absorber and the thermal mass, which are the bronze walls and the concrete slab floor. And then the distribution is the open space on the interior for that heat to allow to enter the space. So that distribution is a 2-story space on the interior. And then I've just gone through and listed some of the features that you want on the north, east, south, and west of building design, just in general for passive solar. So yeah, it was a ton of fun designing this project. I used patinaed copper, light ash rain screen, and then it's a wood rain screen, and then metal ACM panels and white EFIS. So thank you so much for listening to my presentation.